I said I would tell you about the aurora. It's a great time to be observing and photographing the aurora. The aurora is named after the Roman goddess of dawn, Aurora. Aurorae are not specific to Earth. Other planets can have them too. And we're getting more and more images, and we'll probably see even more of them off the James Webb Space Telescope. Around the North Pole, we call them Aurora Borealis. If you didn't know, the South Pole has them too, and they call them Aurora Australis. That's not Aurora Australia. Borealis means northern, and Australis means southern. There are also constellations called Corona Borealis, the northern crown, and Corona Australis, the southern crown. They're very similar, two types. It's possible for them to appear elsewhere, but usually they'll originate from the poles. It all depends on space weather. Now, space weather is electromagnetic radiation from the sun and charged particles. And anything that's close enough to the Earth to have an effect on us, our technology, or our weather even, or to create aurorae. These are the kind of impacts from space weather. It can interfere with GPS because of magnetic and electromagnetic pulses, electrical power, aviation perhaps, satellites for sure, space exploration and communications, and also creates the aurora. This is where they originate from the sun, and it travels as a storm with something called solar wind. There is a vacuum. Space is a vacuum, so there's no actual wind in space. What this is charged particles heading away from the sun, and it heads in all directions. So some of it heads towards the Earth. And the Earth, as you probably know, has magnetic fields coming from the poles. And magnetic fields, if you looked at a magnet with some iron filings, would tend to look like that. You get bits coming out the poles, and the rest loop around. And what they actually are, in the case of a solar wind or a solar storm, are Earth's defenses against really harmful effects of this stuff, especially the radiation. So the sun continually produces this solar wind made of charged particles. When we get an aurora, one way to think about this is that it's the Earth's defense mechanisms being triggered. These huge magnetic fields are repelling them. And sometimes they're so forcefully repelled, and because they're so highly charged, it's like an electromagnetic explosion, and it just shoots these particles off away from the Earth towards our upper atmosphere, where it's much safer for us. We don't want them coming to Earth, thanks very much. And when they collide with atoms and molecules in the upper atmosphere, the energy comes out as bursts of light. So if you see video of aurora, especially around the polar regions, you'll see it moves around and shimmers a lot. What that is explosions. Really big, powerful explosions. So solar activity, all of these solar winds, this solar weather, has a measurable cycle. It's approximately 11 to 12 years, this cycle, we think. We've been measuring it for about 25 cycles now. And we can predict what's going on by looking at sunspots, how they appear and the size of them and the position of them. Sunspots are just where you see blotches on the sun of heightened activity. So we went into solar cycle 25 in December 2019. So that was the solar minimum. That was the beginning of it, the lowest amount of activity with weather, with solar weather. And the peak will come sometime in 2025, we think. So that adds up to being half of approximately 11 or 12 years. And then the other side of that, it'll head back towards the minimum, 2031 maybe. What that means is we're going to get more and more aurora as we head towards 25, and then for 2 or 3 years, the other side of that. Use apps to get alerts. Aurora Watch UK is free. It's run by Lancaster University. It's cross-platform, Android and iPhone. So get it. If you don't live in the UK, I think it still covers other countries, but go into the App Store for your phone and just look for Aurora. You'll find a few free ones and a few paid ones that aren't very much at all. They all do pretty much the same thing, but there are some that are really good with the way they break down the forecasts. And also you can look at NOAA, which is the organization behind weather in the USA, the National Aviation or something like that, I think it stands for, Aviation Authority, and look for Aurora 30-minute forecast. That will show you this. So it'll show you what's going on Aurora-wise and the probability using that bar and that color scheme. There's Aurora Watch. Aurora Watch a few years ago went crazy. Normally we look for a KP of 5, 6, 7 for good Aurora visibility from the UK, certainly from the north. This went really, really high, and everybody got really excited. Photographers were all over the place, as were astronomers. And it was later revealed that the sensor for this is in someone's garage, and it had picked something up from a lawnmower engine. So it's not infallible, but that hasn't happened since. That was a fun day, though. So when you look at these apps, it will show you the predicted KP. If you have a KP of 3, you can see it from northern Scandinavia and further north and Greenland. The next band is KP5. So KP5, you'll definitely see it from the top end of Scotland, but you may see it further south. At KP7, it's going to be across Scotland, northern England, probably even as far as the Midlands. KP9, the whole of the UK is going to get it. So this, of course, is the distance from the pole and how far that energy travels. But for a really good solar storm, you're looking for about KP7, but 5 might just about do it. 9 almost certainly will, but that's pretty rare.